Hello, my name is Tushar Kumar and my SAP ID is 600011900055. Today I'll be performing the first DLIC experiment where I'll be making an inverting amplifier and I'll be demonstrating this using a circuit simulator software known as LT-Spice. So let's get started. First we need to create a new schematic by clicking on this button. Next, I'll be pasting my components and I'll be using the OP07 op-amp. We can also use TL081 or LM741, but I'll be using the OP07 op-amp. So to get it, we click on the component button and type in OP07 in the search bar. There we have it. I'll place it here. I'll click escape because we don't need any more op-amps. Now I'll place the voltages. We can choose it from the component section or simply type V. Here we have it. This will be our input voltage. This will be VCC. This will be VEE. All right. Now, in order to get the resistors, we can type in R. We can rotate it by using Control R. This will be my R1. This will be my RF, which will be my feedback resistance. And yeah, now we need ground. One for this here and this. All right. Next, we just need to connect the component using wire. So I'll just do that. See? Uh, yeah, then yeah, and now I'll just rename my components. This will be RF1. This will be R1. This will be VCC. Oh, wait. This will be VCC. So sorry. Will be VEE. Uh, I'll give it 15 volts. 15 volts. 15. Yeah. And uh, I'll choose 4.8 here, 4.8 kilo ohm, and this will be 1 kilo ohm for a gain of 4.8. Sorry, 1 kilo. So sorry. And this for the input voltage, I'll be having a sinusoidal wave. So we right click on this, select the advanced option, and we choose the sine option. DC offset will be 0. Amplitude, let's say it's 2 volts for now. That means 4 volts peak to peak. And frequency 1 kilohertz. All right. Now we go to the simulate option, edit simulation command. Stop time can be 5 milliseconds, so 0.005 seconds. We list it here. Now we just run it. We put a probe here, and this will be for output. All right. So this green waveform shows our input waveform, and this blue waveform shows our output waveform. We can see that the output waveform is 180-degree out of phase since it's an inverting amplifier, and the input is 2 volts as we had taken it here. And in order to check the output, we select this, and here. Oh, wait. Oh, how do I bring it here? So sorry. All right, so we have got the value, and it's close to 9.6, and 4.8 into 2 is 9.6, so it's close to our theoretical value. That means it's correct. And now let's just tweak the value and let's see what difference do we get. Let's make the amplitude as 5 volts, and let's run it. So here we can see that the output waveform gets clipped off. And what does this mean? This means that the op amp is now driven into saturation, and we can see the value here. Let's bring it here. Yeah, so we can see the value is now 13.95, which is close to 14. So at 14 volts, the waveform gets clipped off. And now we will see the parametric sweep. In order to do that, let's make this 10, and we need a variable resistance. So we put curly RA. All right, and then let's, yeah, this seems to be fine. Let's close this first, and you go to the spice directive and type dot step param, the variable resistor name, RA, 1 kilo ohm to 10 kilo ohm, steps of 1 kilo ohm. All right, place this here and we run it. Now put the probe here, this probe here at the output. All right, so we can see that we just need to count the lines now. This will be 1, 2, 3, 4, 5, 6, 7, 8. So at the eighth line, that is at around 8 ohms, the voltage, the output waveform gets clipped off. So this was the parametric sweep. Now let's look at the frequency response. So using that, we can get at which response the at which frequency the output waveform turns into a triangular shape. So in order to do that, let's change it back to 1 kilo ohm. It will be 4.8 kilo ohm, and it will be 2, the initial value which we had taken. Let's change the frequency this time to 6 kilohertz, and run it. And here we just need to put the probe on the output terminal. You can see that it's almost triangular now. Okay, so but it's still not very clear, it's not crisp. So let's put it at 8 kilohertz maybe, and we'll run it. Yeah, all right, and put it here. Cool. So this is a very crisp triangular shape, and thus at 8 kilohertz we get a frequency response. Correct. Now I'll show you the non-inverting amplifier. I've already made it, so I'll just open it. Oh, I'm sorry. Open DLIC for the non-inverting amplifier. All right. Here we can see that I've taken the feedback resistance as 3.8 because the formula for gain in inverting amplifier is RF by R1, whereas in non-inverting it's 1 plus RF by R1. So 3.8 plus 1 gives us 4.8. And here we can see that the uh, negative terminal is grounded, and we are applying the input to the positive terminal, and this is the non-inverting amplifier. We'll just run it, and uh, yeah, I'll just put the probe here, output here. All right, so we can see that the output is in phase with the input because it's a non-inverting amplifier, and the waveform gets clipped off similar to the inverting amplifier. All right. So yeah, this was it for the first experiment. Thank you.